Hello everyone, welcome back to our YouTube channel. The topic to be discussed is on series combination of resistors. So first of all, let us understand what does this series combinations of resistors mean. Resistors are said to be connected in series if the same current flows through each resistor when some potential difference is applied across the combination. So now let us consider three resistors of resistance R1, R2 and R3 connected in series as shown in this figure. So now let Rs be the equivalent resistance let us also mark here this point to be A and this point here to be B. So now let VAB be the potential difference between the terminal A and B of the network. Let us also consider that these resistors are connected to a voltage source as shown in this figure. So clearly from this figure, the current I will flow in this direction. Let me mark this point to be X and this point to be Y. So let us also consider that the potential difference between point A and X be V1, potential difference between X and Y be V2, and the potential difference across Y and B be V3. So since VAB is the potential difference between the terminal A and B, and I is the current flow through each resistors, therefore we can write VAB equal I multiply by Rs. Here Rs is the equivalent resistance. So let me mark this one as equation 1. So clearly from this equation 1, we can also write VAB divided by I. This is equal to Rs. Also, from this figure, the potential difference between the terminal A and B can be written as VAB equal V1 plus V2 plus V3. Since this current I passed through R1, it also passed through R2, it also passed through R3. Therefore, V1 is equivalent to I R1, V2 is equal to I R2, and V3 it is equal to I R3. So therefore, we can write VAB equal, instead of V1, I will put I R1. Instead of V2, I can put I R2. Instead of V3, I will put I R3. So this is VAB equal, I can take common I. So I can write R1 plus R2 plus R3. So this implies that VAB divided by I I'll take this I to this side. So this is equal to R1 plus R2 plus R3. But as we can see from this equation, VAB divided by I is nothing but Rs. And this is equal to R1 plus R2 plus R3. If n number of resistors are connected in series, the equivalent resistance can be written as Rs equal R1 plus R2 plus up to Rn. So now we will discuss with the parallel combination of resistors. Resistors are said to be connected in parallel if the potential difference across each of them is the same and is equal to the applied potential difference. So in this figure, we have three resistors, each of resistance R1, R2, and R3 connected in parallels. Suppose this is a point A and this is a point B. The potential difference between these 2 points A and B can be written as VAB. This potential difference between 2 points A and B can be written as VAB. If RP is the equivalent resistance, then we can write VAB equal IRP. So this can be written as equation 1. So from here, we can also write that 1 by RP is equal I divided by VAB. Here, I is the current flowing through this network. So as we can see from here, this current I, on reaching this junction, it will get divided. So now, let us assume that the current that passes through R1 is I1. The current that passes through R2, it is I2. And the current that passes through R3, it is I3. So therefore, this current I can be written as I1 plus I2 plus I3. Since VAB is the potential difference across each resistor, so we can write VAB is equal to I1 R1. Also, VAB is equal I2 R2 and VAB is equal to I3 R3. So this can be written as VAB divided by R1. This is equal to I1. Then VAB divided by R2. This is equal to I2. And we can also write VAB divide by R3. This one is equal to I3. If we substitute this value of I1, I2 and I3 in equation 2, I is equal to VAB divide by R1 plus VAB divide by R2 plus VAB divide by R3. So from here we can take common VAB. So we can write 1 by R1, 1 by R2, 1 by R3. So from here we can also write I divide by VAB. Okay, if we take this VAB to the side, so we can write I by VAB equal 1 by R1 plus 1 by R2 plus 1 by R3. So this I divided by VAB is nothing but 1 by RP. So here we can write 1 by RP. This one is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel, we can write 1 by RP equal 1 by R1 plus 1 by R2 up to 1 by Rn. Now we will solve these numerical problems. The question says, find the resistance of the circuit shown in figure between the points A and D. So as we can see in this figure, this is a point A and this is a point D. So now let us mark this point to be C. Let us mark this point to be B and this point to be C. So now we have to calculate the equivalent resistance between these 2 points A and D. So first of all, let us redraw this circuit. Say let me put here A, let me put here D, somewhere here it is B, and somewhere here it is C. So as we can see from this figure, these 2 points A and B, the resistance is this. So we can do like this and draw like this. This one is 4 ohm. Next, in between these 2 points B and D, the resistance is this. So again, this one, it is also 4 ohm. Now, in between these 2 points A and C, As we can see from this figure, the resistance is this 4 ohm from A like this to C. So the resistance is 4 ohm. Next, in between these 2 points C and D, as we can see from here, in between these 2 points, the resistance is 4 ohm. So let me mark like this. This one is 4 ohm and this one is 4 ohm. And now, in between this point B and C, the resistance is also 4 ohm. This point B and C, the resistance is 4 ohm. So here the resistance is 4 ohm. So clearly from this figure, we can remove this resistance. Now, the resistance across AB and the resistance across BD, these resistance, they are in series. So this one and this one, they are in series. So let me mark by RS1. So this series one is 4 ohm plus 4 ohm. So this will become 8 ohm. So similarly, the resistance across AC and the resistance across CD, this is also 8 ohms. So let me mark this one by series RS2. This 4 ohm and this 4 ohm, they are in series. So therefore, what is RS2? We can write 4 ohm plus 4 ohm. So this one is equal to 8 ohm. Now, if we redraw this circuit, now it become like this. This one is RS1 and this one is RS2. So this RS1 and RS2, they are in parallel. So this is a terminal A and this is a terminal D. So therefore, the equivalent resistance across terminal A and D, we can write RP. So this one is equal 1 by RS1 plus 1 by RS2. So from here, we can write 1 by RP is equal to 1 by 8 plus 1 by 8. So from here, we can write 1 by RP is equal 1 by 8 plus 1 by 8 mean 2 by 8. So 2 into 1, 2 into 4. So clearly, it implies that RP equal 4 ohm. So hence, the equivalent resistance across A and D is 4 ohm. So RAD is equal 4 ohm. Now, we will solve this question number 2. And the question says, find the resistance between the points A and D. So as we can see from here, this is a point A and this is a point D. Let me mark this point by B and this point by C. So now let us redraw this circuit. Let me put here A, let me mark here as D, and here as B, and here as C. As we can see from this figure, in between these two points A and C, there's no resistance. So here we can join directly like this. Now, in between these 2 points A and B, the resistance here, it is 12 ohm. So here we can write like this. This one is 12 ohm. Now, in between these 2 points B and D, there's no resistance, as we can see from here. So therefore, we can join like this. Also, in between these 2 points C and D, the resistance, it is 12 ohm. So therefore, we can write 12 ohm. And finally, in between these 2 points B and C, the resistance, it is also 12 ohm. So therefore, we can write like this. So this is 12 ohm. Now, these 2 points A and C, there is no resistance in between these 2 points A and C. This implies that this point A and C, they are coincide. Similarly, this point B and a point D, there is no resistance. So this point B and D, they are coincide. So now, let us see from this figure. In between point A and B, the resistance is 12 ohm. So I can write like this. 12 ohm. Then, in between the points C and D, the resistance is also 12 ohm. And also, in between the point B and C, the resistance is also 12 ohm. So this is C and this point is B. So resistance is 12 ohm. So now, we want to calculate the resistance across A and D. So as we can see from here, this resistance 12 ohm, 12 ohm, and this another 12 ohm, and this 12 ohm, they are in parallel. So therefore, we can write 1 by Rp is equal 1 by 12 plus 1 by 12 plus 1 by 12. So we can write here 1 by Rp is equal. So 1 by 12 plus 1 by 12 plus 1 by 12 mean 3 by 12. So 3 into 1, 3 into 4. So this implies that Rp is equal 4 ohm. So hence, the equivalent resistance across the terminal A and D is RAD equal 4